So I'm Venkat Gopalan. So I'm going to share my screen and give you a very brief introduction. Then you have a very exciting day ahead of you, a virtual exciting day ahead of you. So I'm the chair of the graduate program, and I'm going to tell you a little bit about our graduate program. It's very special compared to maybe the other schools that you might be looking at, considering, and so on. So this is a very nice mugshot of some of our graduate students recently taken. We are the Department of Material Science and Engineering at Penn State. And our program, you'll notice, is called Intercollege Graduate Degree Program. So it is materials, program in materials, but it is across all colleges, which is the unique thing I was talking to you about. So today's agenda is the following. I'm going to keep my remarks brief, but you're going to have a number of people walking you through, even giving you virtual lab tours, which are really fun. You'll see both Stidle Building and Millennium Complex 2 of the centers where a lot of facilities and a lot of faculty reside. Okay, and you'll have various types of materials, including computation, soft, hard, and electronic materials, and so on, that you'll learn more about. Excuse me. Okay, um, this is my group. So if you are interested in knowing more about us, Google Unlocked without the K, ultra-fast nonlinear optical characterization group. And that's all I'm going to say about our group. But I want to tell you more about our program. Um, we are number one in material science and number two in materials engineering, as ranked by the National Science Foundation 4 years in a row. So you are currently considering one of the top programs consistently. And I have to say, I've been here for over a quarter century at Penn State, and we have consistently been there. And this is reflecting, for example, how much money NSF is sending to any given place. And over 2 decades, consistently sending us this kind of money for research tells you something about the kind of place you're considering today. Okay. Um, so what is this intercollegiate thing, which will be different, as I promised you, compared to other programs? It is the following. The materials program has really 152 faculty. So the materials science and engineering department has about 30 faculty or so on. But then you also have all the other branches of engineering and basic sciences you can think of, where faculty work on materials physics, materials chemistry, materials biology, computational materials. If they have interest and their research intersects material science, they are welcome to consider one of you through the materials program and be your advisor, as long as they satisfy the requirements of this program, which is, I'll tell you more about that. So this is the unique part of it. So you really have a much bigger pool of faculty, in fact, almost anybody on campus. And if they are not on our list, they can always become part of our list if they are related to materials. Okay, so so you should have your eyes open for across the university, in addition to our department. Okay, so that's me. I'm the chair. The co-chair is Dr. Pat Lanahan in engineering, science, and mechanics, so another department, as you can see. Sue Hyde is here on the call. Haley Barnes is here. So these are the people who are really the machinery behind all of the stuff that's happening today. So if you have any sort of doubts, they're really experts. And if any sort of questions you have, let them know. If we can't get back to you right away, we'll get back to you as soon as possible. Okay, so what is this program? We call this IGDP, Intercollege Graduate Degree Program, in materials. you can imagine that when you have that many branches of science and engineering all sort of coming together into this very fertile ground, which we call material science, um, then we have to have courses that sort of cater to everybody. So the core courses, which we feel sort of cut across all of these fields are thermodynamics, kinetics, and crystal chemistry, and they're your core courses. So unlike maybe other fields where you may have many more required courses, the number of core required courses is minimal, and then you need a few other 9 credits of other 500 level courses. And these, a couple of seminar course and so on, but these could be anywhere in any of these departments. It depends. If you are doing biological sciences, you may want to take courses in, the Hux Institute of Life Science and, biochemistry and so on and so forth. Okay. Um, all right, so some of those details are here. Um, Qualifying exam is within the first year to year and a half, a comprehensive exam within 2 years, and a final dissertation. Okay, and if you have questions, more detailed questions, we can talk about that later. We have professional development. If you wanted to, teach, we don't have a teaching requirement because again, our faculty come from almost everywhere on campus. So we don't, act in the same way as a pure, Department of Chemistry or Physics or Electrical Engineering might act and give you certain requirements. So if you need or want teaching experience, just ask, and we'll make that happen. And usually, on a practical level, almost all grad students have some experience before they graduate, and often more than one semester. Okay, and so some of these things we have Materials Day, which is a big item at Penn State, and it again cuts across various departments, a lot of industries, companies, national labs, a whole bunch of people come here together, all tied together by materials. So it's a huge festival sort of day. It just ended recently, just a few weeks ago. So that's something that's again unique about our program. Um, if you want to get into our program, you have to find somebody who is interested in you. And so you will come in with assistantship. So that's the good thing. You'll come in with support. You're not going to come in and be looking around for support. But the flip side of it is you have to do your homework now. And as I mentioned, we have a very wide range of faculty. You will probably know the kind of things you want to do. You can narrow down. They may be in the material science department, great. They may be in other departments, great, but you have to contact them. You have to put their names down on your application so that they can look at your application. So you might wonder when you apply what happens. All of this goes into a central database where about maybe 400 of you are applying. And all of those applications are available to all of the faculty. It's not a centralized processing unit, right? So everybody, I can look at all 400 and so can every one of my 150 colleagues, right, in this program. But they are not going to have the bandwidth to look at every single one. You want to make sure that you put in the key people that you're interested in and why, and that may catch their attention. They can filter the list based on whether you have shown interest in their research group. So don't hesitate to put down multiple people, to contact them before your application, during, after, at all times. And so if they say yes and you say yes, then you're coming to Penn State, and congratulations and welcome. Okay. Um, we cover both assistantship and stipend and tuition. So you're not paying tuition, but your advisor is. And so we call it tuition remission. And we have healthcare. You can look at all the healthcare costs. It's covered, health, dental, vision, and so on. and there are some details. We'll share these slides with you so that you can look at it in greater detail. There's a link here too, which gives you much more detail. Okay. And so State College is a beautiful, scenic, lovely place, and you are going to, the cost of living is very affordable, and you're surrounded by nature. And so I came in, 26 years ago, and I just loved the place, so I never moved. Um, and so one of the things is that if you are looking at other offers from, say, a university based in, New York City or San Francisco or something, the cost of living there is going to be much higher. And so you want to be able to compare cost of living to the stipend, and you'll find that this is so what we offer for State College is really excellent. Okay. Um, as I mentioned, we are uh, intercollegiate, right? And you might be interested to know that Materials Research Institute, which is an umbrella organization, so it is an umbrella over all of these 152 faculty, for example, but it's really beyond that because the facilities are available to anybody on campus. And this beautiful building almost looks like an atomic force microscope tip here with a beautiful uh, uh, a little cutout for sunshine and a Zen garden underneath. And right underneath this garden is state-of-the-art electron microscopes and very, very sensitive equipments, which are all open and free. So one of the things I'm going to tell you is that the facilities at Penn State in terms of materials research are probably the best in the United States. You will have to go to a national lab to see the kind of things that you'll see in a university here. And we are sort of the object of envy in this case. And many schools come and sort of try to emulate what we are able to do um, with professional people and so on and so forth. So you're going to have walkthrough, and so I'll sort of leave it. I won't take the punchline out of other speakers coming through, but this Materials Research Institute has all of these departments, a lot of the square footage full of uh, goodies. It's almost like I call it the Toys R Us, right? And the students just love it. And once they get out into the real world, they often come back and tell me, wow, we didn't really realize how good we had it, right? When we were here. Okay, these facilities are fully staffed. You're going to learn much more about all of the characterization techniques in there. And that's one of the buildings, right? And that's a centralized facility in some of our materials faculty, but that building also houses materials faculty from across campus. Now, the materials science and engineering department, right? The department has about 30 plus faculty, and they're in the Steidl building, this beautiful building out here. And so a number of them are housed here, and you're going to get a walk through here as well. Okay. And lovely places to hang out, lovely views. You're going to get walked through from, for example, JP Maria's lab out here, full of very shiny stainless steel and all kinds of labs that you're going to hopefully get a feel for today, right? So I'm going to stop there and I'm going to take questions. This is Maher Saber. Thank you, Maher. Uh, do current US visa bans influence how the admissions committee evaluates Iranian candidates? I'd appreciate any insight. Thank you. Yeah, thank you, Maher. That is a fantastic question. We have many Iranian students and Iranian faculty as well, if you take a look. And we are very keenly aware of the great challenges that Iranian students face in even taking exams and coming out and getting visas and so on. And so there might be hurdles, but again, we don't have a centralized committee that sort of decides on all the people we take in. So really, Mahir, if you find the right faculty and if the match is really good, then that faculty is going to want you, if they want you, they're going to do whatever it takes. And they sometimes there may be a delay of 6 months or so to come in, but they'll be okay. But if you are able to come in, say, for example, in spring and not in fall because of the delays. So I hope that sort of at least partially answers your question. Okay. Ahmadullah, what about funding situation at Penn State? Better than previous fall? Um, yes, I mean, I think to be frank, I was worried last spring. And we took a few hits. You all read the news, so I'm not going to put lipstick on that. But um, we are doing quite well. We are very stable. We are not really affected tremendously. I can tell you my own group that we even got new funding and things are looking stable and looking good. So I am expecting fall 2026 to be much better. So another question on applying to multiple programs. Is it limited to only one program for fall 26? Sue, can you sort of clarify that? Can they apply for multiple programs or only one?
You can only apply for one program at a time.
Okay, so that's the answer there. Um, Daberechi Ebonin, I hope I didn't massacre your name there. I didn't join on time. Do I need to contact a faculty before submitting? You are welcome to contact a faculty before submitting, but it's not a requirement. But if you have and somebody is interested in you and you are interested in them, then it makes you put their name down. But even if you have not, but you have looked at their applications and papers, you should put their names down and they will be able to look at your application. Isabel, how are applicants considered for the PhD program if they already hold a master's? Can credits be waived for PhD requirements? Um, uh, you know, uh, there is no requirement that you should have a master's. I take students from all sorts of backgrounds, and I think the core courses will still be required. I don't believe there is a waiver for PhD requirements because it's already pretty minimal. Great to see everybody here, and I truly hope to see some of you in fall 2026. Okay, so thank you, and Haley, take it from here, please.
Okay, thank you. Next, on our agenda, we're going to have our mentor committee present on our mentorship committee and what they do for our students, new and incoming.
Thank you, Haley. So my name is Tiffany Tu. I am a fifth-year grad student in the Material Science and Engineering program. Moving forward, I'm just going to refer to this as MatSE because it's quite a mouthful. I'm excited to talk with you and share with you some information about the mentorship program that we have within our department. So first, I want to introduce the executive board to you. So our faculty advisor for this student organization is Dr. Stephanie Law. She does a lot of work with molecular beam epitaxy, 2D materials, semiconductor materials. She loves running and fixing cars. Again, my name is Tiffany. Like Dr. Gopalan said, this is a very interdisciplinary program, so the Intercollege Graduate Degree Program. I am actually mentored by a faculty advisor in food science, so I get the best of both worlds there. Our treasurer is Nanda, and he works with Dr. Law. He likes F1 racing. And finally, our event planner is Lauren McDonald, who is also on this call. She likes thrifting and sewing her own clothes. So with the Intercollege Graduate Degree Program, we have students advised by faculty mentors all across campus. I have some friends mentored by people in engineering, science, and mechanics, electrical engineering, mechanical engineering, food science. And so in order to help the students stay connected and foster a sense of community, we established this mentorship program. So our overall mission is to foster a sense of belonging and a sense of community within our department because it's so interdisciplinary and spread out. Other things that we focus on, I know the transition from undergrad to grad school, or if you took a tour in industry prior to coming back to grad school, we want to help make that a seamless transition for you. Other things that we do, we answer questions about living in State College and any questions you have regarding qualifying exam, comprehensive exam, required coursework, etc. So the way that we do this, should you decide to come to Penn State to pursue your graduate degree, we pair you with a current graduate student in the program, and we send out a survey based on interest. So we want to set up a compatible pair. So depending on hobbies, research interests, which groups you're interested in joining, we want you to have a friend coming into the program, and we can answer questions about where to live in State College, things to do in State College. These are pictures from some of the programming that we have done so far this year. So we are involved with the orientation event that happens in August after you join the program. So we do a fun icebreaker event just so that people feel more comfortable meeting each other. I know it's kind of daunting and overwhelming at first, but it's a nice way to meet other people in your cohort as well as other students in the program. We had a pottery painting event at a place downtown. So it was a really nice open space where we can de-stress, relax, enjoy some painting together and catch up. In order to facilitate interactions between mentors and mentees, we do incentivize spending time together by giving out $15 Elixir gift cards. So there's a really cute coffee shop downtown. And so hopefully this encourages people to meet up and stay connected. I want to acknowledge Dr. Beasy and Dr. Morrow for supporting our program, as well as our graduate program coordinators, Haley and Sue, who are also on this call. So if you have any questions, we will send out these slides. All of our contact information is included, but I'll keep it pretty short and I'll hand the floor over to Dr. Beasy for a research overview on structural materials. Thank you.
Great. Thanks so much, Tiffany. Right. So I'm going to give a little overview on structural materials and talk about what we do at Penn State in this space, as well as show some of the faculty working in this area, and you're welcome to reach out to them to have individual conversations. So in terms of structural materials, the work that we do taps into a lot of different areas that are of current relevance. So materials for extreme environments or energy. So thinking about things like how do we design and fabricate materials that can operate at high temperatures, high pressures, corrosive environments, or nuclear environments. Thinking about sustainability, so things like material separation and recycling, reuse and lightweighting. So how can we be cognizant of our planet and make sure that we're using our resources in a good way and reusing them as possible. And then finally, looking at things like we have a big presence in the area of advanced manufacturing. So thinking about processing science or additive manufacturing, cold sintering, or other emergent advanced manufacturing technologies. So we have everything from sourcing and making materials and reusing them and designing them, and experimental and computational components in each of these. So if we look at our structural materials, we have work in the area of processing, structure and property. So in terms of processing, all of these have experimental and computational elements to them. So for processing, we can think of advanced additive manufacturing, cold sintering, field-assisted sintering technologies, or SPS, or traditional methods. And then also on this space, thinking about computational thermomechanical modeling and fluid flow, or the understanding of how processing conditions impact what we're making. This then leads into structures. So the evolution of structures we investigate it at Penn State through thermodynamic modeling, phase field modeling, kinetics, and also then experimentally we characterize the structures that we fabricate. So looking at things like phases, textures, defect structures, and then looking at the impacts of the processing and structure on the resultant properties. So things like mechanical, thermal, magnetic properties, using things like multi-scale modeling from everything from molecular dynamics and dislocation dynamics to crystal plasticity, continuum mechanics, different types of computational methods to probe the properties of the materials that we fabricate. So we span the entire spectrum of material science in structural materials. And so then taking a look at some of the faculty that are working in this space, Tarasenko DeBroy's group works on numerical modeling of heat and mass transfer and fluid flow during welding and additive manufacturing. Hojung Kim's group works on electrochemical processes, metal separation and recycling, and issues related to corrosion. Arthur Mata's group works on materials for nuclear power and really investigating the impacts of nuclear environments on the evolution of structure in these materials. Darren Pagan's group works on advanced manufacturing and in situ or 3D characterization of microscale of materials, as well as microscale modeling and data analytics. Todd Palmer's group works on additive manufacturing and welding, as well as powder processing approaches. Doug Wolf's group works on multi-layer coatings, functionally graded coatings, ultra-high temperature ceramics, refractory metal alloys, and nanocomposites. And then my group works on multi-scale experimental and computational mechanics, additive manufacturing, and then we've got a new project in data science-driven sustainable materials processing and design. And then finally, I just want to put one slide up here, or one little segment up here to kind of emphasize that we also do have this large presence in additive manufacturing of everything from a heavy focus on metals, but also we have ceramics, polymers, composites in this space. So we have a center for additive manufacturing here at Penn State, if that's something you're interested in. Also, you can feel free to reach out to any of these folks as needed.
All right, I think I'm up next with the computational materials aspects. And so I have here a collection of different methods that are used by our faculty, and all of these graphics are coming from publications from our faculty. And so computational materials is more of like a method side rather than a specific material focus. And so here we have experts in quantum mechanics, where we're looking at very small collections of atoms. We have empirical force field experts, where we're looking at larger collections of atoms. And then we go up to like phase field and CalFAD modeling. We have some extremely well-recognized experts in those areas when you're going beyond atomistic scale. We also, if you keep going up in scale, have experts in finite element methods for different applications. And then sort of out here in the corner, we have some statistical mechanics work, which is, not necessarily representing these directly, but sort of thinking about how atoms interact in a more abstract way. And so we have quite a lot of research going on in these areas, but I also wanted to highlight another kind of methodological aspect of our program. We have more and more expertise in machine learning and AI type methods. And so, for instance, Allison mentioned we have this new project in data science for manufacturing traineeship. And so we're thinking about these interdisciplinary problems. And so again, all of these graphics are coming from publications from our faculty. So we have a number of people that are working on scientific computer vision, so applying machine learning to microscopy and other types of characterization. People working on ML acceleration for, let's say, empirical modeling of atoms. My group and some others are working on language models for science. Dr. Pagan's group's working on some ML surrogate models, and then, a large number of our finite element type folks are working on this kind of area. And then myself and a few others are working on what I just put on the slide here, machine learning methods, just to indicate that sometimes when we bring machine learning techniques into a domain science problem, it requires new ways of doing the machine learning as well. So we dip our toe into that area as well, even though we're housed in a material science department. So here is a little bit of a roster of our core computational faculty in MatSE. And I noted a couple of things on this slide. In addition to the names, I noted that some of these people also have a significant experimental component. And so Dr. Beasy especially is one of those people that I work with that is generating both experimental and computational data. And then also I tried to list some of the methods here, like, finite element and phase field and so forth. So you kind of know what types of topics these people work on. And the other thing that I will note is that we have several active faculty hiring searches. And so this list will be growing, I think, in the near future. Beyond our core faculty, I also have an incomplete list here of IGDP computational faculty. So as you heard earlier, there is a very extensive roster of faculty that are affiliated with the program that can be your advisor. And so you'll see a large collection of different departments represented here. And these people all have a significant computational component as well. So you could think about them or look at the list if you're interested in learning more.
Hi, I am Nayati Sinha, and I'm an assistant professor in the Material Science and Engineering Department, and I'm going to introduce the polymers and soft materials research that is pursued in our department. So as you have already heard from other professors who have talked today, our department is very interdisciplinary, and polymers and soft materials research sort of spans many different application fields that are studied by our faculty. Some of them are highlighted here: composites and blends, colloidal nanoparticles, and biomaterials and biomimetic materials are some of the fields that specifically our faculty are interested in. But some of the questions that we truly try to ask ourselves and build on is how to make these polymer materials and their composites more sustainable, more functional. And so there are flavors of these questions in all of the research that is being pursued in this field in the Material Science and Engineering department. So I just wanted to highlight some of the professors and their areas of research, so you get familiar with who to talk to if this really interests you. So for polymer composites, we have Professor Hickey, who works on all types of polymer chemistry and physics. He was recently the winner of the Dillon Prize. And his group works on pre-ceramic polymers, polymers in extreme environments, and also polymers for sustainable polymer discovery applications. The other professor that works in this field is Professor Wang. He works more with ferroelectric polymers and device fabrication, and his group is more involved in conducting or ferroelectric polymers. Then when it comes to biomaterials and biomimetic polymers, we have quite a few professors who are interested in this field of research, including myself. There is Professor Pan. He works on smart molecular medical devices. Professor Hasegawa, who works on cancer drug delivery systems. And the Professor Pan and Professor Hasegawa both are also affiliated with the biomedical department, engineering department. So you get a lot of expertise in biological materials and applications in those kinds of fields. My research is mostly oriented towards biomimetic polymers, so synthetic polymers that are derived from nature. So I study mostly polypeptides and polypeptide polymer conjugates for making complex materials. Then there is a significant component of polymer and colloidal physics and theory that is pursued in our department. There is Professor Colby, who is a renowned polymer physicist and a rheologist who is also actively hiring students. Then there is Professor Lopez. He studies mostly polyelectrolytes and biologically relevant polymers that are charged, as well as ionic liquids. And he's also involved in a lot of neutron and X-ray scattering experiments, so if that's interesting to you. And of course, Professor Reinhardt, who already discussed computational science that is being pursued in our department, is also an expert in colloidal self-assembly and discovering new materials using computational techniques. So the department is extremely interdisciplinary, and we all work with each other to tackle questions related to sustainability and more functional polymer research and discovery. What I want to leave, and there's also professors who work with conducting polymers. There's Professor Dumont. His group studies photovoltaics and optoelectronics using polymers, and also Professor Gomez, who is currently involved in electronic polymers and solar cells, but also works on cellulosic polymers, which is a bio-derived material. All right, I want to part with saying that we have some of the most excellent facilities that you can find on university campuses. And as someone who works in the polymer field, these are extremely important for polymer characterization, material characterization in general. And I just want to leave you with this information that we have the Huck Institutes of Life Sciences, if you're more interested in biologically derived polymers and soft materials, as well as the Materials Research Institute that houses a ton of different facilities. And because of that, you get exposure to excellence in polymer research, because we have world-class characterization facilities and research staff. And you as a student will get exposure to these if you do join our department.
So good afternoon, everyone. I'm Matthew Crone, so I'm the department head of the Electronic Materials and Devices Department at the Applied Research Lab here at Penn State. And I'm just going to give you a brief overview of the materials research that happens here and a little overview of what the Applied Research Lab is here. So the Applied Research Lab is one of the nation's 15 university-affiliated research centers, so it's a UR. We're one of the 5 that are funded by the Navy. And really, Penn State ARL enables our DoD customers by helping them leverage advanced technologies so they can advance and sustain their critical assets. And we've been doing this for more than 80 years. We are a large interdisciplinary research organization within Penn State University. And so as you've already heard today, there's a lot of basically interdepartment and intercollege kind of collaboration. And so we're one of those, we look to collaborate with the university. So we maintain a special long-term strategic relationship with the DoD, and we really focus on delivering critical research and people to solve DoD issues. At the same time, we're here to contribute to the education and research that's aligned with the mission of Penn State University. And so I just wanted to highlight, there's 1,500 employees at ARL, 15% are students, right? And so we look at employing undergraduate and graduate students, and I'll talk a little bit more of the work we do in the area of material science. So there's 5 offices within ARL. The one I'm going to focus on today is our materials and manufacturing and sustainment office, and then there's an enterprise operations office which supports us. And we, as some of the other faculty members have alluded to, we really do kind of focus on having world-class research facilities on site to be able to deliver this research. So within the materials manufacturing and sustainment office, we cover the entire DoD asset lifecycle. I think with the work that I do and some of the other materials professors within a research faculty within ARL, I'm going to focus a little bit more on the modeling simulation, but really the advanced material solution and manufacturing areas. We work closely with the defense and the defense various sponsors and the industrial base to really understand what their problems are, identify where we can have solutions or provide value, and then accelerate the adoption of those technologies. At the same time, we work closely with faculty members within the university on the academia side in various colleges to help transfer their technologies into these demanding applications. We have multiple areas, again, the material science and applications and advanced materials and materials engineering, along with our electro-optics and electronic components divisions, are probably the ones that most closely align with the materials research at Penn State. Just to give you a little flavor of the work we do here, we do a lot of work in advanced materials development. So either across all the materials, so soft materials, metals, ceramics, semiconductor materials. So formulation development of new phases and or processing techniques. We specifically are looking at high performance materials and processing for harsh environment and extreme environments. We have a group focused on advanced coatings and different ways to improve functionality of systems. I focus on electronic materials and devices. So my group focuses on ultra wide bandgap semiconductor materials and additively manufactured materials. We have a group in Pittsburgh on optical materials. So these are application of various optical and electro-optics type materials. And then advanced sensing, we have a group focused on various materials, supply chain processing for developing new materials, polymer composites and manufacturing, and then fabrication, process development, and expeditionary manufacturing and repair. So these groups all focus on designing and developing and then validating and trying to prototype and get to scale. And we work closely with the faculty members within the department. We offer various fellowships, and at the time of recruiting, we'll engage with various faculty members to make sure that those are communicated. But in the meantime, I'm happy to answer any questions or follow up with me if there is any more information. Thank you.
I'm going to be presenting for John Paul Maria. I'm a second-year grad student in his group. My name's Ian Mercer. Here, I just kind of want to give a tour of our lab and also talk about some of the projects and electronic, optical, and magnetic properties of materials that we're looking at. So just to start off, in the background, this is our laboratory in Steitel. We have many different collaborators that span across the US and internationally, which is really exciting in terms of doing the best research possible. Some of the facts about our lab: we span a really large area in Steitel, so 2,500 square feet. In essence, what we do is we use physical vapor deposition tools to deposit really thin films and thin coatings of materials that have interesting electronic, optical, magnetic, or mechanical properties. In our lab, we also do a lot of powder processing. So sometimes there are certain compositions or materials that are not widely available to buy from vendors. So we have a lot of leeway to make our own powders and then deposit thin films with those. And in terms of projects, we get lots of support and funding from the US government. There are some questions earlier about funding. JP is really good about funding and always has money for students. So that's really important, especially in times like these. To go through the lab, there's different sections. First, we have kind of the ferroelectrics sections. So in 2019, quartzite materials were discovered to be ferroelectric. And so we have many deposition chambers that focus on nitride or oxide quartzite ferroelectrics, which are extremely new and have kind of a meteoric rise in the ferroelectrics community. We also look at optical materials, so nitrides and oxides for infrared nanophotonics and photonics. So these materials are really important in terms of plasmonic responses and interesting optical properties. We also have chambers and tools that work on ultra-hard carbides and borides, so making thin films of metals or materials that rival diamond and boron nitride in terms of hardness and mechanical properties using chemical disorder. And quantum is extremely important moving forward in the future. And so we also have quantum projects. One example of this is calcium oxide. So we can use and grow really high purity calcium oxide, which is a good defect qubit host and very magnetically inert. And we also have high entropy oxide systems and PLD systems where we can understand basic thermodynamics of systems that have extremely high entropy. And we can even use extremely high entropy to basically stabilize certain properties or structures or different kind of anything that we're interested in. And there's a lot of freedom in those systems, and they're really important right now. We also are able to do powder processing that enables us to make these specific compositions that may not be accessible. Now, one of the things that really makes our lab special is how much characterization we have in-house. So in JP's lab, we have our own scanning electron microscope. We have our own X-ray diffraction or diffractometer. We can also do ellipsometry in the visible or the IR spectrum. We can look at different compositions with X-ray fluorescence, surface roughness with atomic force microscopy, DSP for calorimetry data, and we also have an extensive electronic suite. So as a student, the kind of throughput is you may grow a film and in the same day you can characterize it with 10 or more different characterization techniques and use all of that data to base your next deposition off of. Like I mentioned earlier, we do a lot of ceramic processing. So we can use powder batching, ball milling, pellet processing. We have many different furnaces in our lab that we can control the atmospheres to get the right stoichiometry of targets or different compositions that might be kind of strange or interesting. We can also look at calorimetry data, and in essence, our kind of ultimate goal is making thin films of these materials, but we can really support that thin film deposition by making really high quality solid state ceramics. And so, like I mentioned earlier, we focus on mainly 6 different research activities to show some of the recent interests in these materials. Just for example, the novel ferroelectrics, we recently showed that we can take materials that for many years have thought to be not ferroelectric or non-ferroelectric and induce ferroelectricity in them in certain conditions. And we can go even further by making proximity structures so that we can induce ferroelectricity in materials that normally wouldn't exhibit those properties. We're also in the kind of optical property regime. We can use oxides and nitrides to really push forward certain optical properties and tunable optical properties. For the high entropy oxides, we're starting to look at ferroelectric properties, but we can also use them as ion conductors, correlated electronic materials, and even ferromagnetic properties. Like I mentioned, there's also the quantum materials. So we're making these qubit hosts with high purity and designer defects. So we can tailor the different types of defects and tailor whatever properties the quantum computing people may want for quantum devices. And we, for thin film processing science, we're always trying to understand our thin film synthesis better. So we're using this to kind of push that forward in the field. And we're even starting to look into 2D materials. So there's some work coordinating with the 2DCC, which is a center at Penn State as well, focusing on 2D materials and their properties. And one of the kind of important things that I want to highlight, especially as a student with JP, is that he always encourages very creative ideas. So even though in our lab we might be focusing on getting certain results or trying to meet project deadlines, he always comes up with really creative ideas, and many of his best projects have come from just fun Friday experiments where somebody has an idea and we test it, and on the same day we get something really interesting. In terms of our group in human resources, we have a pretty large group. So we have 14 full-time graduate students. We also have one research fellow and one postdoc. And the importance in this is, since we have so much characterization, so much synthesis, so many resources, it's important to have a framework or kind of a community where we can all train and mentor and teach each other every day. But it also helps when we have visiting scholars or visiting researchers or somebody new coming in. So there's an important framework here. And with that, I want to close out and just say you can contact me if you have any questions, or JP. Thanks.
Welcome to Steidl Building, the home of material science and engineering here at Penn State. My name is John Paul Maria. I'm a faculty member of our department, and I'd like to take this opportunity to give you a tour of our facilities. We're now in the Steidl atrium on the ground floor. This is a large space that is used by graduate and undergraduate students for studying or just relaxing between classes. It is also event space that is used for different research competitions or for different department social events. Steidl Building supports the department administrative activities, the undergraduate laboratories and classrooms, as well as graduate laboratories and office spaces. We're now in room 401 Steidl, also known as the Rotunda. It's a room that's used for lectures, for classes, and very often for student dissertations. This frame highlights the historical transition of Steidl from its original 1929 state to the newly remodeled state that was completed in 2016. Behind me, you'll see a large glass wall behind which are about 21,000 square feet of laboratory space that house a large fraction of our department's graduate research. We're currently in the laboratory space on the second floor of Steidl Building in an area that's occupied by the Maria Group. Our group specializes in thin film preparation, and around me you will see and hear a number of instruments that are used to make very thin coatings, primarily but not limited to electronic materials.
My name's Ian Mercer. I'm a first-year grad student in the Maria Group. This right here is atomic force microscopy, or sometimes called AFM. Right now I'm looking at the surface morphology and roughness of aluminum boron nitride ferroelectric thin films.
Magnetron sputtering is one of the most common methods for preparing thin films. This instrument here is a tool that we developed to sputter calcium oxide. Calcium oxide is an interesting host for qubits, which may enable modern quantum computers.
Hi, my name is Darren Pagan. My research group studies the atomic and microscale origins of the mechanical and functional properties of crystalline materials. We do that through combinations of novel in situ characterization, big data analysis, and computational modeling.
Hi, I'm Lutifafaya Odumo. I'm Professor of Material Science and Engineering at Penn State. Welcome to the Dumo Group. Here we focus on materials for device applications. Our focus is more on organic materials, for example, semiconductor polymers, also on hybrid material like metal halide perovskite. We also work on quantum dot for optoelectronic and photovoltaic devices. Our focus is more on the degradation mechanism and the stability of the devices for application in outdoor or indoor environment. We also push more low-cost fabrication, especially in the metal halide perovskite, where we make them in ambient for research accessibility and any other things that we can think about. Yeah.
Hi, I'm Jensen.
And I'm Mikita.
We both work in Dr. Rob Hickey's group, and we do a lot of polymer synthesis and polymer physics. So we have a couple projects in hydrogel materials, pre-ceramic polymers, and hybrid polymer ceramic type polymer grafted nanoparticle materials. So we're going to take you on a little tour of our lab space. So here we're in floor 318 of the Steidel building. It's a community lab space that are shared between a couple of research groups. The Hickey group is kind of right here in this front corner. This entire aisle, as well as that aisle, completely dedicated to fume hoods and benchtop spaces, where we can do kind of wet chemistry and material synthesis and sample prep inside the fume hoods, as well as lots of storage space for our glassware, our supplies, our chemicals, and any samples we create. So we have kind of this whole deep space. Right on these sides, we have kind of the standard sized fume hoods that are basically have the storage cabinets underneath. And as we come down to the next bank of fume hoods, we also have a couple like full-size walk-in fume hoods that reach basically the full height of the human. So in this one specifically, we have a couple pieces set up. On this side, we have just a vacuum drying line for, in this case, a polymer sample being dried so that it can be used for characterization.
And here we have our flask under vacuum that we got rid of all the oxygen for the anhydrous reactions that we wanted to do. And here we're depositing some tetrahydrofuran in it.
Hi everyone, my name is Urara Hasegawa, Assistant Professor of Material Science and Engineering. And my group is developing polymeric material for biomedical applications. And my group synthesizes polymer and develop nanomaterial, evaluate them in biological systems.
Hi, I'm Mary Kate.
Hi, I'm Jacob.
And we're both part of Dr. Susan Sinnott group here at Penn State. As a computational group, we focus on using and developing atomistic scale models and methods to design and investigate materials and their properties.
And more specifically, Mary Kate and I are a part of the Penn State MRSEC. So this is across different colleges here at Penn State and other universities where we explore high entropy oxide systems using these tools.
What we have here is the computationalists will have meetings, we'll discuss research, collaborations, we'll do our own studying, we'll do homework. Really it's just a space to come together and have open discussions about the work that we're doing. As computational students, we're always looking for whiteboards, and luckily in this room, all the walls are whiteboards that we're readily able to use and write on.
Hello, and welcome to the Sinha Research Group, where we explore the utility of bio-inspired sequence-defined polymers. And we make these out of various combinations of peptides, peptoids, nucleic acids, and their conjugates to assemble the next generation of biomaterials and nanocomposites. Using high-throughput synthesis and characterization techniques, we screen to identify unique sequence-driven and molecular-driven structure property relationships that can alleviate material design limitations in healthcare, energy, and sustainability fields.
Hi, I'm Shaylee, and I'm a graduate student at Penn State.
Hey, I'm Jess, and I'm also a graduate student at Penn State.
And we're part of the Morrow Group. The Morrow Glass Group works on a very diverse set of research,
all related to glass, but we also work on glass coatings,
on glass ceramics, computations and simulations of glass.
We also work on fundamental structure property relationships of glass, working on making glass more sustainable for a more environmentally friendly future. And we work on things that are very specific applications like glass bottles or bioactive glasses.
Good afternoon, everybody. My name is Dave Thecko. I get the pleasure of telling you next about our Materials Research Institute in the Millennium Science Complex. We're a minute or two ahead of time, so I'll take the opportunity to give you a little better introduction. I've been at Penn State for about 15 years now. I am a part of the Materials Research Institute. I do industry outreach for MRI. We have the institute structure at Penn State is alive and well. We sit in this building behind me, the Millennium Science Complex. We have 4 other institutes on University Park campus and 2 institutes at our Hershey Medical College. The institutes cover a broader swath of the university than an individual department. And for example, as Venkat was saying earlier, Professor Gopalan, we have about 25 academic departments that do some sort of materials research, and they are all part of the institute Materials Research Institute. And that also has over 350 faculty involved. So there's a lot of areas that you can get involved in materials research at Penn State. As Professor Gopalan mentioned, also we do have very good funding support for materials research. We're #1 in materials science and #2 in materials engineering. Those are NSF numbers for funding in materials research. I did see a question about what the current funding situation is at Penn State. I will give you a little bit of advance notice. Our funding has increased 8% from last year. So even with the current situation in the government, we're now over $1.4 billion of research that we do at Penn State. So we are a big research powerhouse. Personal side note, you'll get to hear from some of the graduate students here soon about the area. I love this area. It's fabulous. I hope you decide to come here. Personally, I'm a fly fisherman, so I get out to enjoy the streams in Penn State, around the State College area all the time. And I would be happy to tell anybody more about that when it gets to that point. Let me go ahead and share my screen. I'm going to pull up a browser here and tell you a little bit about the Millennium Science Complex. So I showed you the picture of the building. It's, you know, my background here. So in the Millennium Science Complex, we have 3 large user facilities or shared use facilities that are open for use by graduate students. The nanofabrication lab is one of them. We also have a 2D synthesis center called the 2D Crystal Consortium, and then the materials characterization lab that's in the basement. We'll get there in a second. Let's go in the nanofab and show you what it looks like in here. So we're now in our nanofab. You can see the room lights are kind of have an orangish color to them. They don't have ultraviolet content in them, which gives them, you know, of course, the other shades that are left in the spectrum. So we've got the reds and the oranges and whatnot here. In the nanofab, we have all manner of equipment for deposition of coatings onto substrate materials. Sorry about that. And then we can do this is your test to see how good you are at you know, this is your spinning you around test. Okay, so let me head down. Sorry, I think I'm supposed to go out here. Okay, now we're in the clean room. We have deposition tools. We have lithography tools. We do all manner of nanofabrication research in the clean room. It's about 10,000 square feet of research space. On Friday this past week, the board of directors at Penn State approved a $31 million expansion of our clean room. So we'll be adding a lot of capabilities for advanced packaging capabilities. So that'll you'll see you know, an expansion of the current facilities, and that'll greatly improve our research footprint. Also in the Millennium Science Complex, under the garden area. So we're going to go down under the garden area, which is where our low vibration lab spaces are. We also have extensive X-ray diffraction capabilities. You'll notice a couple of things in here. One is that we do tend to buy equipment from one vendor. So our vendor of choice for the X-ray diffraction equipment is Malvern Panalytical, and that gives us kind of purchasing power to be able to buy equipment at a good cost, and also service contracts. So I'll put these links into the chat when I leave here, but you can go down and kind of explore each of these pieces of equipment if you care to. You can get a little more detail on the different pieces of equipment in the X-ray diffraction lab. Then also very important to us is our electron microscopy capabilities. we'll take a quick peek into one of the rooms where we have our scanning electron microscopes. This is one of the SEM rooms. We have 4 SEMs in this lab. All of them are outfitted with EDAX X-ray capabilities for identifying, elemental composition. They're all high resolution field emission electron guns. So these are kind of top end pieces of equipment. Also, we're adding, we've just installed the latest high-end aberration corrected TEM. This is Thermo Fisher's Spectra TEM. So it's about a $10 million microscope. But all of these instruments are available and are frequently used by graduate students. So if you do choose to come to Penn State, you'll be using some of the best equipment that you could possibly get for your graduate studies. Another comment about the staffing. So we have about 75 staff members in the building. Over 50 of them are in our 3 facilities, the core facilities that I mentioned, and they are there to support you, to do training, to make sure that the equipment is being used safely, to provide maintenance on the tools, and also to give you help if you have questions about different techniques or analysis of the samples that you're looking at. So anyway, just know that as far as capabilities go, and for materials research, we've got that covered for you. So if you decide to come here, this is where you'll be doing a lot of your work. This, and of course, Steitel building is the two buildings are where you'll be doing the majority of your work. Thanks very much.
So we are going to talk a little bit about living in State College and what it is like to be here as a graduate student. So geographically, we are located right in the middle of Pennsylvania. We're about 3.5 hours from the middle of downtown Philadelphia and about 2.5 hours from Pittsburgh. Those are the 2 largest cities in the state of Pennsylvania. And then we're also pretty centrally located to other major cities like DC and New York City. There are things to do within the Northeast, of course. You just might have to travel a little bit out of State College. We'll talk about what to do in State College, but this is kind of the general geography. To get here, a lot of people will fly directly into State College. We do have an airport. You could also fly into one of the bigger airports and then drive or take a bus or take the train from one of the larger cities.
So where to live? A lot of grad students live honestly all over at these different stars on the map to the right. On campus is a popular one for grad students who don't necessarily have cars or just want to be really close to where they work. Downtown is also very popular for people who don't have cars because you can easily walk right to campus and to other restaurants and things downtown. And then more of the other locations that seem to be more suitable for the grad students who do come with cars just because they are a good drive. You can't really walk from these locations like Toft Trees, South Atherton, North Atherton, and then 2 other towns that people sometimes live in is Bellefonte and Bullsburg. I personally live out in Bellefonte. It's about a 20-minute drive to get to campus, but to keep in mind, Bellefonte is a lot of people say it's just quieter. There's less hustle and bustle because it's not really State College where the university is.
It's also a little bit cheaper in rent. The further away you live from campus, the cheaper rent is. All right, so to get around, like we just said, you could walk and bike, right? If you live on campus, if you're downtown, it's very accessible to walk and bike. There's bike racks everywhere. There's also spin bikes, which you can rent for short term on campus. You can drive. There's commuter parking passes all over campus. Depending on which building you work in, you might get a different parking pass, either Steitel or the Millennium Science Complex. It is very convenient to have a car to get groceries or to get away from the weekend to go exploring within the Northeast. But you do not have to have a car because we do have a bus that works very, very well. There's a Cata bus system all over State College. And within campus, there's free buses for downtown, which are the red link, the blue loop, and the white loop. And so you can just hop on and hop off, especially when the weather gets cold. The buses are very nice to get across campus. There's also Uber, of course, just like anywhere, and it's pretty useful to get to and from the airport if you don't want to park at the airport. The airport's only 10 to 15 minutes depending where you are in town, so it's not very far, but the Uber is a good option. Or if you want to, go out with your friends for a night, Uber is a great way to get home.
So some things to do on campus. Of course, all over campus they have different gyms and recreational places. Am I able? Oh, I can't turn my pointer on because it's not me. But
Oh, yeah,
the
you're good.
top image is our biggest gym, which is the IM building, and it has workout facilities as well as rock climbing and other indoor sports like badminton. And then we also have the Creamery that's right on campus, which is one of our main tourist attractions for people coming to Penn State, is they love to get the Penn State Creamery ice cream. That's also very closely located next to the IM building. Again, another thing that people love touristy to see is just our Lion Shrine. A lot of Penn State alumni come to take pictures with it, and just Penn State students in general. We also have two pools on Penn State's campus. One is the indoor pool, and then there's also an outdoor pool. Of course, the season's subjected. You're not going to be swimming outdoors in the wintertime, which is why they have the indoor pool as well. And then we also have an art museum that was newly renovated and relocated near the Arboretum, which is another attraction here at Penn State. And then one other museum we do have is like the All Sports Museum. So these are all typical things that a lot of people see like once or twice, but the gyms are a good commodity since there's 3 and they're located throughout the campus. So if one's closer to you than another, we do have the freedom to go to any one of the 3.
Within the department, we also have department-specific events for you to be involved with. For example, we have the ice cream social, we have the apple cider bar, we have the chili cook-off, we have an annual picnic, which is really a good welcoming event at the start of each academic year, and that takes place at a local park. We have the Millennium and Saddle Cafes. These are research-focused events where someone will present their research in a short talk, and there's normally coffee or food provided, which is awesome. And then there's also things like research fairs where students have the opportunity to present their work without traveling to a conference, and that's really nice to be able to get feedback on your research, but locally. You don't have to put all the effort into booking conference travel and being gone for a week. You can just simply utilize the experts we have on campus through the research fair and presentations like that. There's also a lot of really fun events. In the bottom, you can see a group of students that did pumpkin carving during Halloween. There's all kinds of fall festivals. And the department also supports that with like the apple cider bar. And then we have various events within the Steidl building within the MSC. So this is a bottom picture. It's like a board game event, which was very fun.
So some things to do in the area, we mentioned at the beginning that you can drive and leave and go to more populated cities to do things, but there are things to also do here. There's a lot of hiking, of course, outdoor areas here. There's Shavers Creek that has a wild bird exhibit, which we have yet to be able to make it to because it's been closed every time we've tried to go, but I did hear it's pretty nice. We also have a lot of different restaurants and bars, wineries and cideries in the area that you can go to. We, of course, have local movie theaters and bowling alleys. Another thing we have Tussey Mountain, which in the winter, it's ski slopes and tubing. And then I believe people also hike there in the warmer seasons. And then we also have a fun place called the Rivet, which is like a crafting place where you can go and you can use their equipment. They have 3D printers. They have sewing type machines where you can just make all different kinds of arts and crafts. And they also have classes there to teach you how to do different things.
So there's some seasonal events, and these things happen about once a year, or maybe just throughout a different season. So first of all, we have Wings Fest. This happens throughout the summer on Wednesdays, where they have live music and just a fun event where you can get chicken wings. There's the Grange Fair each summer. That's in the next town over towards Center Hall, PA, and it's a very fun fair where lots of people actually camp out there for the whole week, but it's really fun to just visit for a day. There's a costume parade. We didn't know about this until this year, actually. So this happens around Halloween time. There's the Central Pennsylvania Festival of the Arts, which is a very popular event for the whole state of Pennsylvania and beyond. At this festival, there are hundreds of vendors selling various crafts and art. And this kind of shuts down the downtown streets for a week, which is very fun. Good time in the summer. And then, of course, we have Penn State football games in the fall. And as a student, you can buy a Penn State football pass, which gets you access to all of the football games for a season. And then there is Thon, which is a large Penn State organized event supporting, cancer patients. But it is mostly supported by undergrads, but grad students can definitely be involved also. Awesome. Thanks so much.
Okay, that is the conclusion of everything for today. Thank you everyone for joining. And if you have any questions, feel free to reach out to our program. Our email address is gradoffice@matse.psu.edu, and you can also find this on the MatSE website as well. Thank you, everyone.